My time is up. Thank you for coming out for my talk. I wanted to talk a little bit today about the upcoming winter, and then I really don't like to talk about climate change anymore. It's more discouraging as the years go on. But Craig asked me to talk about it, so I'll try to talk about it and not be too depressing. Start with my outlook for the winter of 2015-16. No idea. Okay. It's a really big El Nino, okay? It's a good chance it will be certainly one of the top 3 El Ninos. The other big ones are 82, 83, 97, 98 since about 1950. This just happens to show you the departure from average sea surface temperature in the Pacific. In the tropical Pacific there, that huge tongue of red that you see there along the equator, that is indicative of a very strong El Nino. It's already developed. That's in part why we have strong confidence that this winter is going to be a strong El Nino year. And the basic problem, though, for Utah is we have virtually no correlation of our snowfall with El Nino or La Nina. This is just data from the Alta Guard station. Every 3 months during the winter, these are running 3-month periods versus an index that measures the strength of El Nino. And as you can see here, you just got buckshot there. So, you know, if you really want to know, I don't know who left their phone up here, but somebody's calling for you right now. Thank you. So anyway, it doesn't do us very much good for predictive skill, but if you're a big skier and you really want to walk out of here with some good news, the 82, 83 events, the 97, 98 events, the 2 biggest ones, those were actually pretty good years in the Wasatch. Now, as a scientist, sample size of 2 doesn't do it for me, but you can sleep good thinking of that tonight. The other thing I think that maybe is a little more likely, it's a pretty good bet that winters are going to be above average these days, in part because of climate change. And El Nino also stacks the cards a little bit for the western United States to be above average for temperature. Not a lot, but you know, if I had to put a little bit of money on it, I would go more towards warmer than cooler, but we'll see how it all comes together. Craig asked me to talk about global warming. So I'm going to talk a little bit about that, and this is actually based on chapter 9 of my book, Secrets of the Greatest Snow on Earth, so that's just a little bit of a nice plug. If you want to read about climate change, how it's going to affect the Wasatch Range, that's a good place to look at it. So here's where things sit right now. This is the global sea surface temperature, or global temperatures since 1880, the average for the whole planet. Everybody probably is aware here, things have been warming a lot, and 2015 is going to set an all-time record pretty easily by the time all is said and done. So what we're looking at here are January to October temperatures, just so I could put 2015 in there. And you can see 2 big pushes of warmth. One was 97, 98, that big El Nino. We're in a big El Nino now, so it's no surprise that we're going to have a record-setting temperature. And every aspect of the climate temperature or climate system is responding in this way. I always laugh when people are talking about, oh, there's some uncertainty in these records. There's no uncertainty that the Arctic ice is disappearing. It's no uncertainty that glacial ice is disappearing all over the place. This is happening all around the planet. The oceans are getting warmer. It's a massive response of the climate system. We have a lot of different ways that we try to figure out what the causes are, and the vast majority of evidence points to the fact that the warming since about the middle part of the 20th century is dominated by the influence of humans, mainly the increase in greenhouse gases. This is just one example of one of the things that we do. This is kind of an ensemble of climate model runs where we include the increase in greenhouse gases and other human effects, and then where we take them out. So we just have natural effects. If the planet was left to its lonesome, to do nothing over the last 60 years, if we hadn't had humans on the face of the earth, it probably would have been about the same temperature today as it was 60 years ago, maybe even slightly cooler. That's what the vast majority of evidence shows. Now, when you go to Utah and you start talking about what's happening in Utah or any other one part of the Earth's planet, then each winter is somewhat dependent on the whims of the jet stream in that particular winter. So if we look at the long-term trends in Utah temperatures, you can definitely see an upward trend. Utah is warming faster than the global average, so we're warming a little bit faster here than the global average temperatures are, but we also see a tremendous amount of variability from year to year, and that's what makes the year-to-year expectations so difficult. Last year was a very warm year. We could end up having a really cold winter, say this winter or next winter, just because of the winds of the jet stream. I'll talk about that a little more later. But if we look, these are average annual temperatures for the whole state. Utah has not had a year with a below average temperature, average for the 20th century since 1993. Okay? The odds of that happening by random chance is something like 1,000,000 to 1. Okay? So without climate change, you're not going to get that very likely. Now we start talking about snowpack trends for the West. Things can change a little bit geographically and in particular with altitude. So this is one of the graphs that I like to use when I'm talking about climate change. What you're looking at are 9 panels here. The upper left are the lowest elevations of the western United States, so below about 1,000 meters elevation. And the lower right are the highest elevations, which would be, for example, up in the upper Cottonwoods or in Colorado. And you can see that at the lower elevations, you're starting to see now this is the fraction, these are graphs of the fraction of winter precipitation that's retained in the snowpack on April 1st. This is actually one of the best measures you can use to kind of look at climate change because it integrates everything that's happening during the winter. So you can see a pretty big decline in the lower elevations, but as you go to the higher elevations, there's no discernible trend. Okay? So when people are telling you, oh, there's been this huge loss of snow, it really depends on what elevation that you're looking at. The lower elevations, places that are relatively warm, they have a more vulnerable snow climate than the highest elevations. When you're up above 10,000 feet or above 9,000 feet in the Wasatch, you know, virtually all the snow, all the precipitation today still falls as snow. You might get a freezing drizzle event, you might get a little bit of rain. It's all retained. Last year was a terrible snow year. It was incredibly warm, yet north aspects held onto the snow for most of the winter. Okay? Things are different down low, but low to high makes a big difference for the snowpack. We start talking about the future. We're basing our future projections on our understanding of the past, and also kind of projections of the future based on theory, but also computer modeling. A few of the key points I like to try to make is, number one, even if we were to stop emitting greenhouse gases today, we're already committed to warming for the next 3 or 4 decades. Most of what we understand about the Earth's climate system is by increasing the greenhouse gases so rapidly over the last few decades, we've turned up the thermostat in the room. The furnace is now cranking, but we still haven't warmed up yet. Okay? So if we could stop everything today, we're still going to be looking at some warming. Okay? So this is this warming commitment through 2040. Everything after about the middle of the 21st century, though, it depends on what we do over the next few decades. We have a few options. One is we can double down on fossil fuel consumption. This is the so-called business as usual thing and just say, screw it. Forget about solar power. Let's just keep cranking the furnace. And if we have that, then we're going to see very, very large warming by the end of the 21st century, probably on the order of several degrees Celsius. Okay, this is for the planetary average temperature. On the other hand, if we do cut down greenhouse gas emissions, we might be able to contain things a little bit. I'm not here to tell you which is the best path to take, but as a skier, this is the best path to take. Now, the hard thing with the temperature change is it's not going to be uniform across the globe. The Arctic is expected to warm a lot faster than the other part of the globe, and that's exactly what's been going on over the last few decades. That's why they've seen dramatic changes. And the interior of continents are expected to warm faster than other parts of the globe. So Utah is expected to warm faster than the global average. And if we then take this high growth scenario, so say we don't do anything about greenhouse gas emissions, we just continue to burn fossil fuels, these are the estimated changes in temperature, increases in temperature in the central Wasatch relative to, I think this is the 30-year period centered on 1990. So from 1990 to 2040, 2060, 2085. Probably hard to see those numbers, but 2085, I'll be long gone. Maybe some of you will still be around, but it's a net temperature change of about 10 degrees Fahrenheit during the wintertime. Okay? These are big numbers. About 4 degrees Fahrenheit by about 2040. Now, to kind of put that into perspective, let's talk about the vulnerability of snowfall. This is based on past data now. These aren't projections. So basically what we're doing here is we're looking at past snowstorms, we're looking at the temperatures during those storms, and we're asking the question, okay, if it was, say, a degree warmer or 2 degrees warmer, what fraction of the precipitation that used to fall as snow is going to instead fall as rain? So this is like the first order effect. And you can see for a degree Celsius of warming, these are for areas above 7,000 feet, there's not a huge change. But when you start getting to 2, 3, 4 degrees Celsius, then you see large amounts of wintertime precipitation that was previously falling as snow, instead falling as rain in the middle elevations of the Wasatch. Okay? So if you're sitting up at 10 or 11,000 feet, the losses of wintertime precipitation to rain still are not that large because you're so far above the mean freezing level in the wintertime. But if you're down in the lower elevations, okay, you're talking about Spruce's Campground, you're talking about Mill Creek Canyon and those sorts of things, then you're seeing a lot more of the wintertime precipitation falling as rain instead of snow. So the vulnerability is greatest in the lower elevations, and the upper elevations are less vulnerable. I was thinking about in the panel discussion just now, that high north terrain in the Cottonwoods, that is going to be ground zero in the next 40, 50, 60 years. Because just like we saw last year, that's what we're going to see more and more and more of as we move through the 21st century. High north is going to be the place to ski, and it's going to be harder and harder and harder to access places from lower elevation areas that we do today. Now, these are projections for snowfall now for the West, just to kind of bring that idea on. I mean, the good news, as I always like to say, is that we live in a high elevation interior part of the continent. If we were in the Cascades or we were in the Sierra Nevada, things would be maybe a little bit worse even in terms of how quickly change is going to happen. So the losses of snowpack in the Cascades, for example, are going to be a lot more rapid and a lot larger than we're going to see here. And then you see a few other plots there on the right. These are changes in snowfall fraction. This is the water equivalent of snowfall as a function of the temperature of the stations today. So warmer temperatures versus colder stations, or warmer stations versus colder stations. These are snowtell sites in the West. So those warmer areas are expected to see a lot more loss of snow than the interior colder areas. Okay? The other thing that's kind of interesting is the change in snow days. The number of snow days goes down across the board, okay? But colder interior stations see the bigger storms getting bigger. So as we move into through the 21st century, we would expect to see fewer storms, but the storms that we get tend to be larger, okay? This is kind of a consequence of a warmer climate. So people ask me, 2014-15, that was a horrible year, and Governor Jerry Brown of California said this is the new normal. Okay, so I've given a pretty depressing talk, but I want to change it around a little bit. I want to try to convince you that last year is not the new normal. Okay, last year was largely due to climate variability. This is the average snowfall, or the snowfall alta guard for every year back to about World War II. Just to kind of show, last year was a terrible snow year, far worse than 76, 77 in terms of total snowfall. Although 76, 77 was probably a worse snow year because we didn't have as much snow early in the season. If we look at temperatures at Salt Lake City, not only was last year the worst snow year, it was also the warmest year on record during the wintertime. Okay? So kind of a worst case scenario. You can call it a stress test if you want to. But in my view, last year was driven a lot by the fact that Mother Nature set up a pattern that really gave us a really warm winter and a very poor winter. So I don't consider it a new normal. And although it is nice to compare these pictures here, June 2011, remember 4 years ago? Almost 800 inches of snow. Remember how great that was? That was the last year my back wasn't killing me too, which I keep telling people when the snow comes back, my back will feel better. And then on the right, that's from March of last year. June versus March. Pretty unbelievable. That's a lot of variability in the climate system. Now, if you wanted to find a good ski season last year, you need to go to the eastern United States. This is just to kind of highlight that last year was big on variability. Jay Peak, Vermont on the 1st of May, Mount Washington, New Hampshire in May. This is what it looked like in Utah at Snow Basin and Sundance at the same time. The eastern United States had one of the coldest winters they've ever had on record last year. So a quick summary. I guess my point is from last year is don't panic. We're only in the early stages of global warming right now, so 2014-15 is not the new normal. But in the long term, the dice are going to become increasingly loaded for higher temperatures, more wintertime precipitation falling as rain instead of snow, a shorter snow cover season, and a reduced peak snowpack. And those losses, and the way you're going to notice them, is going to be a lot greater in the lower elevations than it is in the upper elevations. And the highest elevations of the Wasatch, we're all lucky in some respects, have more insurance against global warming than a lot of other places on the globe. So that I'll knock off, and maybe I can take a question or two. Thank you. We're also running over by 15 or 20 minutes, so maybe people want to go out and eat a banana.
We definitely have time for a quick question for Jim. Yeah.
Okay. Yeah, I just wanted to say. Okay. I attended. Can you hear me?
I think I may have to repeat the question.
Do I need to switch?
I'll repeat it.
Oh, okay. I have a background in political science and environment going all the way back to college in Vermont in the 70s. But all that aside, I attended 2 presentations this summer in Park City that are particularly pertinent. One was the film Merchants of Doubt. And I would like to encourage everybody here to download that and listen to that movie. This is where they talk about how using cigarette lobby tactics, they're bullying scientists and people like that to create, to counter what real science is. And what's interesting is it's not just another, it's not just another it's not just another conspiracy film, there's extensive interviews. That said, I want to know if you've had a chance to watch that film or...
So the question is, have I seen the film Merchants of Doubt? I haven't seen the film. I have read the book, though. It was based on a book by Naomi Oreskes. I've been involved in this business for a long time, and it can be pretty frustrating to be in. I've never been bullied by anybody in the fossil fuel industry directly, maybe because they don't feel I'm a very big threat, but I do know of some pretty difficult times that people have had. But I like to tell people, this is no conspiracy. 5,000 scientists didn't get together in a room 30 years ago and decide to come up with this. And we've been working on this problem for a long time, and the evidence at this point is quite overwhelming. The real questions are, how fast will the change occur? How much will it occur? And how will it affect things regionally? So I've given a pretty hard talk here where I made it sound like we know everything. We don't know everything, but it's a very serious risk. We're rolling the dice in a very serious way at this point. Yeah, question.
Yeah, I've done some reading on dendrochronology, which is tree ring to climate. Basically, I've read that in the last 100 years has been the wettest period of the last 1,200 years here in the West. And I'm just wondering, did we just see an anomaly and we're all born to be blessed skiers, or are we going to have climatic changes similar like what the Anastasi's had, and it's overnight?
Yeah, well, I think the most interesting thing from the tree ring data is just it helps us understand how much more variability there is in the climate system than we've seen during the 20th century and the first part of the 21st, because there have been these very prolonged droughts in the past that we haven't seen of quite that magnitude over the last 100 or 150 years. I don't know if this is the wettest period. I don't know if I've seen evidence for that. But I always tell people we probably are the best generation of skiing that the Earth will ever see because of the convergence of transportation, unbelievable ski equipment at the right time before the climate has changed substantially. So get on it the next 3 decades and have a good time.